Hi everyone, welcome to our next video on this topic SQL and databases. We just have couple of recap points, and recap points are primarily about set of things that might be and will be tested in your exam. That is, what is the how you compare and contrast single row functions like uh, math, string, or date with multiple row functions or aggregates. So single row functions, they operate on single row at a time, right? It returns only one result per row, and it can be used in everywhere, select, where, and order by clauses. Examples are math, string, and date. Multiple row, obviously it operates on groups of rows. It returns one result for a group of rows. For example, max, min, whatever it is, and it can be used only in the select clause, not in where, order by, and others. Examples here are max, min, average, sum, count, and count star. And these are the example of multiple row functions. The aggregate functions that you say in your MySQL is max. So it will return the largest value from the specified column. Syntax for it is select max of a given column from any table, right? Minimum, so you can get the minimum. Average, so you can get the average of some numeric from the given table. Sum, so it will actually sum it up, right? Count star returns the number of records in a table, right? So in order to display the number of records that matches a particular criteria in the table, we have to use count star with where clause, right? And count on a given column returns the number of values in the specified column, ignoring the null values, right? So select all from manager will be say all these four, but when you say count on mem name, right, from manager, right, so what will be that? That will be only 3 because null value is not considered. Okay, with this in mind, we'll spend some time creating 3 new table: inventory, that is having car id, car name, price, model, year of manufacture, and fuel type. Then we have sale, which will be having invoice number, car ID, customer ID, sale date, payment mode, employee ID, and sale price. And then customer, which is having customer ID, customer name, customer address, and phone and email. And the employee, which is having employee ID, employee name, date of birth, date of joining, designation, and salary. Across these 4 tables, if you see, the car IDs are the foreign keys between inventory and sale, while customer ID is between customer and sale, and employee ID between employee and sale. To create this, this is the syntax that we have chosen. Please follow with me. So I think not so very. Okay. My machine is behaving a little. Okay. So we are having, I wanted to highlight our, this part, create table inventory, and what all we have in our inventory table, car ID. Well, car ID is also a primary key. We have kept it text, car name, we have kept it text, and this can't be null. Price cannot be null, it's a real. Model is a text, it can't be null. Year of manufacture, integer, is not null, and fuel type. You can also, you would have changed it to varchar, and either of that. I should have it fine. Create table customer. So what, as you saw here, customer ID, customer name, customer address, phone, and email, right? Pretty similar. Customer ID is primary key, and email should be unique, right? Not null. So email is a text, it should be unique and not null. Okay, then at the sale table, the invoice number, that is the primary key, car ID, customer ID, or the text kind. The sale date shouldn't be null, payment mode shouldn't be null, employee ID is text, and sale price is real and can't be null. Foreign keys, here are customer ID referencing this table, customer ID referencing that table, and employee ID referencing that table. And then eventually your employees, you have executed it, you got all the data here. Then we have entered actually bunch of records, right? In our inventory, in our customer, in our sale, and in our employee one, right? So before we move ahead, let us actually look at, say our query is to see, right? Our query is to see, uh, select all from inventory. Okay, and then we execute query. So you've got all these number, right? D001, D002, B001, B002, D001. So these are your actually model IDs, model name, price, their brand, year of manufacture, and whether petrol, CNG, diesel, whatever, right? So that's what that we are saying here, that if you want to use, right, let us look at some of the aggregates, right? So say your query become, uh, select mean of which section, price, right? We'll take mean of price from inventory, right? Let us execute query. So you see actually what is the mean. In a similar way, you can control A, control C. You can actually look at max, right? Then you can look at average. Okay, this also helps you, right, many a time figuring out, right, right. So you got average, sum, max. You can actually also look at sum, right? Sum. To get another answer. Now this is not interesting, when you have to work on all of these. Many a time, if you apply some of these, aggregate around group of uh, subset, then you might get, certain kind of answers, which you always need, or which you need in many scenarios, right? So at times we need to fetch a group of rows on the basis of common values in a column. This can be done using a group of clause, group by clause. It groups the rows together that contains the same values in a specified column, right? So we can use this aggregate function on top of this to work on the grouped values, and having clause is used to specify condition on the rows with group by clause. So when you are having select and where, the same is group by and having, right? So say for example you want to display the total number of records from inventory having a model as VXI, right? How you will do it? What your query will become? Your query will become, select, what you are trying to do, total number of records, right? So you can look at count a star, right, from inventory, right, and then what you want to display, the total number of records from table inventory having a model as VXI, right? So what is our table structure for inventory? Let us look at table structure of our inventory is car ID, car name, price, and model, right? So model is the one that we have to look at. So we are trying to find out uh, group by model having uh, and then we are having the having clause, right? Just let us reread this. So display the total number of records from table inventory having a model as uh, PXO. So we don't need to group anything, right? Select count all from inventory, right? Where model equal to LXI, is it? Execute query. What is happening? Oh, we we don't allow double X here. And then what is it? Right? So we have with LXI 2 with VXI 2, right? Now, if you have to count the distinct models, right? Display the total number of different type of model available from table inventory. Total number of different type. So, say for example, so select uh, model from inventory, right? What we get here, LXI, PXI, sigma dot 2, delta dot 2, here LXI, VXI, whatever it is, right? And then when you apply distinct, right? So you get LXI, VXI, and all of that. And what is our ask? Display the total number of different type of models, right? So we have to count distinct of models, right? We have to count distinct of model 6, right? Let's look at what count is doing once again. So if you provide count on a column, it returns the number of values in the sprite column, ignoring the null value. So in this example, let us consider a manager table having 2 attributes and 4 records, right? So when you actually do count on mem name, right, you get 3 because fourth one is null. And when you only do count star, it returns the number of records, and in order to display the number of records, it matches a particular criteria in the table we have in our count star with where clause. Okay. So we looked at display the total number of records from table, display total number of different type of record, display the average price of all the cars with model LXI from table inventory. How you can do this? What you are being asked, average price of all the cars with model LXI. So what you are going to do? Select average of price from inventory where your model is LXI. Simple, right? So what is going to be your query? Select, right, average of. So this is where you can start seeing it now, some of these. Select average of price from inventory, right, where model is LXI. And then of course we execute query, right? Model, okay. There is some typo, let us correct it. We got average price across all these categories. Fine. Um, Display the number of car purchased by each customer from sale table. Number of car purchased by each customer from uh, sale table. So there are several things in our sale table. Let us do our sale table electricity. We are actually talking about these, right? So let us first actually uh, let's start with how our select table is looking right. So our query is select, okay, select all from sale, right? And let us say that we execute query. So this is one of the reason, guys, that I do a lot of pre-planning and prepare some of these material. It also save us time and everything. But for many of you, SQL could be your first time course, and what I want to help you is by writing interactively in front of you while you are watching this video. uh, I want to kind of remove, right, some of those learning issues where when you read through it looks easy, you think like it is actually going to work, but trust me, SQL queries in your life, whether you move in data science or CS field, or even if you go into an analyst job as a BA or whatever it is, right, SQL expertise will always actually give you an edge. And at this stage, it's good that CBSE is having broad coverage around these topics, right? I mean, almost the kind of detail that you had right from introduction of basic table creation, updation, alter, right? Those kind of things till writing involved query uh, using actually several other added on subqueries, right? So this is actually going to help you a lot. And only thing that I can ask from you is practice a lot. Create a lot of table. Go and actually use online SQL interpreter. Go and install simple SQL. Do whatever actually makes you comfortable. But try a lot of these and make yourself comfortable with syntax so that you can actually start getting it naturally. Okay, so we have got all our um, uh, now. Can we describe table? Uh, okay, so what is our describe table? We have invoice ID, car ID, customer ID, sale data, payment mode, employee ID, and Salesforce, right? And what is our first question? Display the number of cars purchased by each customer from sale table. So number of cars. So what will be number of cars? Count of it, right? So this is where, let's look at what all you are having, right? So your query for this, right? Your query for which one? Display the number of cars. Display the number of cars, right? Purchased by each customer from sale table, right? So how your query will look, right? Right, try and write with me. Select. What you are trying to do, you are trying to find out count, right? And on the car IDs, right? So you want to count on car ID, right? Purchased by each customer. So what you have to do? From sale, now you actually do group by. Okay, group by what? Customer ID. Let us look here. Query, execute query, and then we pass query. We got issue. Customer ID, syntax error. Hmm. Oh, we have not used it here, right? Okay, okay. So select customer ID and count, right, of car ID, and then we are trying to say, so customer ID syntax error from sale, right? Okay, okay. This group ID, we are having a lot of fun today. This is what that you learn, right? Now let us see that count of these, right? Number of car. Anyway, we are actually not getting some of our intermediate levels, right? So display कर दिया हमने, display the number of cars purchased by each customer. Display the customer ID. Okay, display the customer ID and number of cars purchased if the customer purchased more than one car, right? Okay, so what we are going to do, how our query is going to be, select, right, customer ID, then we have our count of car ID, right, from sale, and then we group by customer ID, and then we have our having clause, right? So having will say that um, our count star, right, is greater than 1. Okay, execute query by there are no such column CRID. Okay, this is the advantage, right? When you write it, customer ID, car ID, you got it, right? So all the customers greater than 1. Okay, so we have your having clause here. Okay, display the number of people in each category of payment mode from the table sale. Display the number of people in each category of payment mode. Each category of payment mode. Okay, let us see how we can do this. So our query is going to be select what we are saying, select display the number of people in each category of payment uh, 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 describe table sale, right? So we are having invoice, car ID, customer ID, sale date, payment mode. So this is saying that display the number of people in each category, and how you'll get the number of people in each category. Invoice, car, customer ID, sale date, number of people in each category of payment. Okay, so select count star, right? Um, and then what you are having here, payment mode. From cell group by payment mode. Okay, execute query. Okay, payment mode. Yeah, this group by, right? So we have got actually all these people by each payment mode, count star, and what you can do, you can have your payment mode here as well, right? Select payment mode and count star, right? So bank to check, and then if you want, you can actually to put some other condition you can do, right? Okay. Display the payment mode and number of payment made using that mode more than once, right? So more than once will actually require us to more than one requires us to do what? Um, right? So we are already having this query. Let's cut and paste. And then you'll be having an having clause, right? Having count star, greater than 1. right? So you got it. Okay. I will just take few more minutes uh, talking about the um, join one, right? So we just in last video we talked about Cartesian product, but cardinality will get employee and attributes multiplied and attributes will get added, right? Many a time Cartesian product is too much, and that's where join comes into picture, right? So join operation combines tuples from two tables on a specified condition. This is unlike Cartesian product, which makes all possible combination of tuples. While using the join clause of SQL, we specify conditions on the related attribute of two tables within the from clause. Usually, such an attribute is the primary key in one table and foreign key in another table. So if you actually create, we already have, right, around our inventory, right? And what you can do if you want to do some of the select, right? What you do is when some of your uh, conditions, right, are matched. So Cartesian product we have already seen, right? Let us do one thing. Let us describe table, right? Invoice. Okay, and then describe table sale, right? So what all we are having? Invoice number, car ID, customer ID. It is not printing this one, man. So this is our sale, right? This is our invoice. No, inventory. So it's not checking for inventory. So card ID, car num. So you have car ID that is common, right? So how you write a join statement out here, right? Select, right? So say if you want to combine, right, uh, and take. So what you will get actually from inventory, you have price, right, and model, right, and from sale, you might be having sale date, right. So from how you'll actually write it, select all, right, from. So let's actually first do select all from inventory, and then you can actually give a abbreviation, right. Select all from inventory and then sale, right. Um, where inventory car ID, right, equal to sale का car ID, right. Let us execute query. So you got all of these, right, where these car IDs are same. Why? Because rather than doing now, select all, now you can do meaningful selection, right, from across the common. What you like to select, right? Um, you'd like to select, say, um, you know, car ID, customer ID, sell date, payment mode. So say that you are interested in sell date, payment mode, right? Uh, Sell price, right? And say price, maybe, right? Uh, okay. Now we'll actually go for this little letter. Um, Let us write out proper join, right? Uh, Rather than what you do, select all from this, right? Select all from uniform this, join this on this, right? So select all from inventory this, sell this, uh, right? Join sell, yes, on. Let's say got the same output, right? Okay. Um, there are explicit of natural join, which actually removes the redundant one, because there could be some entry, right? Which might be, let us see if natural join is supported here. No, I mean, so this syntax is not supported. Let's not complicate it. Okay. So only thing that will be actually, if two tables that you are joining here, right? By default you are looking at inner product, and depending on your need, you can actually look at leftmost or rightmost part of it by changing your uh, join type. So let's stop here. In next video, we have to kind of quickly cover some of the question. Thanks guys for being here so far. Do subscribe and like our channel. Comment any changes or any specific logic topic that you want to be covered, and let us uh, see you in our next video, which will be final one, where we'll give you some of our questions on SQL side for CBSE.